The motion picture you're about to see examines the basic relationships between the meteorological phenomena of temperature, pressure, and wind. The instrument you see here is a demonstration barometer. A barometer is an instrument that responds to pressure changes. This barometer consists of an airtight rubber diaphragm covering a plastic dish that is filled with air. Attached to the diaphragm is an arm that pivots with the movement of the diaphragm. Pressure can be artificially produced in this barometer by pressing down on the diaphragm. What happens to the dial when the diaphragm is pressed down? The long arm of the dial pivots on the fulcrum upward to a high-pressure reading when the diaphragm is pressed down. You will now observe how changes in air pressure can also force the dial to respond. The demonstration barometer has been placed in an airtight chamber. You can see that the barometer dial moves upward to a high-pressure reading when the rubber lid of the chamber is pressed down. Why does this happen? As the rubber lid is pressed down in an airtight chamber, the air molecules are compressed together. High pressure is produced. The pressure is great enough to force the yellow diaphragm down, and the dial moves to a high-pressure position. Note the valve at the side of the airtight chamber. Smoke is released near the valve, which is now open, so that you can see the air movement. When the valve is open, what is the direction of the airflow? The smoke reveals that air was rushing out of the chamber. What happens to the air pressure as a result of the airflow? This flow of air, or wind, continues until the spacing of the air molecules inside the chamber equals that outside the chamber, and pressure is again equal. Can you describe what happens when the valve is closed and the rubber diaphragm is pulled up? Closing the valve and pulling up on the diaphragm causes the air molecules to spread out. This action reduces the pressure inside. Now, study the movement of smoke as the valve is again opened. What direction does the air flow? When the valve is open, air rushes into the chamber. How does this air movement now change the pressure inside the chamber? Air continues to enter the chamber until the pressure is again equalized. As a result of this demonstration, what can you generally say about the direction of airflow as indicated by air pressure? Air will flow away from areas of high pressure and into areas of low pressure. In this demonstration, the wind was brought about by artificial pressure exerted on an enclosed atmosphere. In a natural setting, however, other forces act to cause pressure differences. The next demonstration will show the relationship between temperature and air pressure. The barometer is placed on a piece of dry ice. What type of pressure is indicated by the dial? When the barometer is placed on a block of dry ice, the diaphragm is depressed and the dial moves to the high pressure position. Next, the barometer is placed under a heat lamp. What does the dial show about pressure in relation to warm areas? Under the heat lamp, the dial shifts to a low pressure position. How would you generally describe the relationship between pressure and temperature as a result of this demonstration? Cold areas are associated with high pressure. Warm areas have low pressure. For this final demonstration, an open-mouth bottle is used. The bottle is subjected to the same conditions of cold and heat as the barometer was. This procedure will create the same pressure conditions that cause wind. The bottle is first placed on a block of dry ice. What is the direction of airflow at the nozzle of the jar? On the block of ice, air blows out of the nozzle. Why does this occur? This results from the high pressure produced inside the bottle. The bottle is now placed under the heat lamp. Now what is the direction of airflow at the nozzle of the jar? Under the heat lamp, the airflow reverses itself and is drawn into the bottle. Why does this happen? This results from the low pressure created inside the bottle. Airflow into or out of the nozzle continues indefinitely as a result of the open mouth at the top. Can you explain what must be happening at the open mouth of the jar when it's on the block of dry ice? On the block of dry ice, air settles into the open mouth of the bottle to replace the air forced out of the nozzle. What do you think happens at the open mouth of the jar when it's placed under the heat lamp? Under the heat lamp, the air is pushed out of the open mouth because of expansion, allowing the air to flow in at the nozzle to replace it. You have seen in this motion picture that unequal heating causes pressure differences. You have also seen how these pressure differences result in a predictable air circulation. Although the airflow attempts to equalize the pressure differences, the persistence of surface temperature differences maintains the air circulation. This has been the story of the relationships between temperature, pressure, and wind, an important part of understanding the weather around us.